to help you.
Wait, so I lost some of that, and part of it was I was distracted by this.
I think that wasn't a good explanation. I think it would help though.
And, okay, so why does that help as opposed to two humans?
Something stationary, something that's not gonna move. Something that you can actually fight against. Cause like, Andre, was it, right, yes, sir? He was saying that he was trying to pull it tighter, but he was also pulling his partner, with him as well. The doorknob is not coming with you.
All right. So why was he pulling his partner?
Cause I was too weak.
No, not a matter of, I've seen two really big guys on both ends and someone small still touching it to the ground. Yeah. For the most part, you two didn't have a chance. But,
Is it the thinness of the rope?
the only difference that the thinness of the rope should have made would be that it, just to keep it from breaking.
Is it because the distance between them was further than the distance between the rope and the ground? So it's easy for me to push it down?
That has something to do with it, but I'm suspecting based on the way you worded that, not for the reason you're thinking. I could be off in my interpretation. All right, let's think about, we gotta connect this back to forces at some point. All right, do you think that Andre and Aisha were exerting a force?
Yes.
All right. Do you think that Lay was exerting a force?
Yes.
Okay. We got three forces involved there. I'm assuming that the weight of the rope is negligible. We don't have to worry about it. So we got three major forces acting on it. What can you tell me about those three forces?
One was going down and the other two was going apart.
And that brings us to a major important aspect of forces. Direction matters. Most of the effort that Andre and Aisha were exerting, most of the force they were applying were against each other. Thus back to pulling, one of you is pulling over. The doorknob would help because you aren't going to move the doorknob. However, if the rope were tied there and Aisha were pulling with the rope on the other side, she would basically be pulling herself. Or the force that she applies would be pulling her towards the doorknob. But direction matters. So most of their effort, though, was against each other, and very little was opposing Lay, especially at first. Now, it looked like there were a couple times you did one finger and then you switched to your whole hand, especially that last time. Why?
One, because they started pulling a little bit tighter. That was one. Two, I kind of felt my hair slip up a little bit.
Oh.
I wanted to get it over with.
Okay. Think about at first, Aisha, Andre pulling this way. There's absolutely nothing to oppose Lay. At the end, Aisha is now pulling at an angle here. Andre is pulling at an angle. There's now some part of the force that's acting up, and some part of the force most of the force is still acting to the side. So it gets harder the farther you push because more and more of the forces that they were exerting were upwards.
Okay, if we were elevated and we're pulling up and she was pulling down, would that have any effect on it?
Then you get into another aspect of sort of muscle control. But yeah, I mean, in theory, if you were just as strong holding the rope up here as down here, then yeah, she would have experienced the resistance faster. If they were shorter, sorry, reword that. If Aisha and Andre were closer together, then the forces they would be applying would be much more upwards. And so more of that force that they're exerting is opposing leg. And that's why I have the rope far enough apart, because I want that angle to be as small as possible. All right, so force, direction matters. And when direction matters, and the amount that they were pulling mattered, we are dealing with vectors. How many of you have dealt with vectors before? All right, so I think that's one. One of you willing to admit it, at least that I saw. Presumably, you have not dealt with vectors in kindergarten when you're asked to count or asked to, how many things are on the table. You go 1, 2, 3, 4, 5. You don't worry about direction. Direction doesn't matter when I'm counting items on a table. Those are not vectors. When only the magnitude counts or the amount counts, that is known as a scalar. Now, there's a good chance you are familiar, you have not used the term scalar before, but this is the type of math that you've been doing since you first started doing math. So kindergarten or pre-K or whenever it began. Or first grade, I guess. Kindergarten is not required. So, if I talk about scalar math, that's just the math you've been doing. Vector math is going to be new for most of you. Because direction matters. So, first off, how do you know if something's a vector or a scalar? Well, some of it you can think through. Force, the direction the force is applied does matter. If I'm going to close that door, it does matter which way I push. Direction does matter, so it is a vector, but there's also symbols that we use to indicate we're dealing with a vector. And so, typically in class, this is what I'm going to be using. I'll put this little, what I call a half arrow over top of it. Well, tests and quizzes, I do something slightly different because, well, I got a word processor, I don't have to write it. The full arrow. And it doesn't matter which way the vector is actually pointing. The symbol right here is always pointing to the right. Some students have wanted to change the direction of this arrow based upon which way the force is going. This is just saying, hey, we're dealing with a vector here. Some textbooks and some websites will do it a little bit differently. This is not realistic as far as what I do in class, because boldface, sometimes places will boldface it. And then sometimes you'll see what I call the double print. All of these would indicate we're dealing with a vector. This is the one right here that I tend to do in class. Now, usually all I have to do is give you the vocab word, and you should know force is a vector quantity. Velocity is a vector quantity. Speed is a scalar quantity. Those last two are chapter 3 stuff. Acceleration, well, that's a vector quantity, and it's also the word we use for the scalar quantity. Again, chapter 3, you don't have to worry about it right now, but it'd be really nice if they had two different words, but they don't. All right, so suppose I have a vector, and this represents a vector itself. This is the symbol I would use for the actual quantity, so, I could write, this represents a force to the right of 3 newtons. Then I could write that the force is equal to 3 newtons to the right.
Would you ever put to the left?
If I had for pointing to the left, I could. So this would be, if that's 3 newtons, this is the force equals 3 newtons to the left. However, I used to talk about physicists and mathematicians being lazy. my wife corrected me, so she's right. It is that we're trying to be efficient. So writing out to the right and to the left, there's actually a shorter way of doing that. All right, questions up to here before I introduce a new type of vector, since you're experts on it now. Because I don't feel like writing out to the right and to the left over and over again, so I'm gonna shorthand. I introduced the unit vector. The purpose of the unit vector is to indicate direction. The size of a unit vector, or the magnitude, is 1. No units, it's just 1. Because the whole point of a unit vector is to indicate direction. We do something similar. If you think about money, if I have 5 $1 bills in front of me and someone asks me how much money I have, I'm not going to say I have 5 $1 bills. I'm going to say I have $5. It's understood that, you know, it happens to be in $1 bills, but that's not the important part. Now, how do you recognize a unit vector different from other vectors? You got a different symbol for it. Of course. You have some letter to represent it, and then you put a hat over it. And occasionally I look up what that symbol is, what the official name is, and I keep forgetting. So if you had French, I know French uses the hat. I was hoping somebody would just throw out what it's called. If you're actually using OpenOffice or LibreOffice and you're writing a formula, if you want that symbol to show up, hat is actually the key word. So I would speak this as I hat. That's how I would say it. And so now I need to somehow indicate that it is going to, what direction I hat is, because the direction of I hat depends upon what I say. I have that power. And on your papers, you have that power. So what I'm going to do is I'm just going to write I hat to the right like that. I could have written it to the left if I had wanted. And so this right here is now equal to 3 newtons I hat. So I'm replacing this whole term to the right by this symbol. It will make life easier in the end. Questions to hear?
If you were going left, what would it be?
We're about to do that.
Oh, okay, my fault.
Other questions before we answer that one?
So this is just to indicate the direction of which something is going?
Yeah, instead of having to write out words, it's just shorthand. I would write that at the top of the problem or the page, or where I'd write that somewhere, and that's indicating now that way is I hat, or I hat is that way. All right, to Nathan's question. That would indicate to the left. If I said I hat is to the right, how do I say it's the opposite direction?
Odd pants. That's what it is.
I was thinking that.
It's not the traditional way of doing it. I guess you could define that, but there's a simpler way. If you were trying to write as little as possible, so.
Efficiency.
I guess you're thinking of something like that.
Yeah.
All right. Think about a number line. Flashback to number lines. You got zero in the middle, you got positives on one side, negatives on the other side.
Okay, so you would do a negative
negative
I hat?
Exactly. So, where the negative shows up, there's traditional ways of doing it, you gotta be careful, I've seen too many people do this wrong. So I wanna indicate the opposite of what I've defined, so it is indeed a negative, and you stick the negative in front. Negative 3 newtons I hat. Now, some people wanna put the negative right in front of the I hat,
That's right.
and what they ends up looking like is 3 newtons minus I hat. So if you wanna stick it in front of the I hat, I don't recommend it, but that would be, this is still acceptable, however, not traditionally written this way.
So that negative indicate is going to the left.
This negative indicates to the left,
Mhm.
opposite of the way I've defined it.
Cool.
I can feel the excitement mounting. You know something's coming. Tears of joy, that's what I'm assuming. All right, so let's see how this actually plays out. I got a box pushing on one side with 3 newtons. And we'll just start out with that. Let's go ahead and define that to the right is I hat. So what would I write down as the total force acting on the box?
Would just be 3 in I hat.
I do want to point out one thing here. You said N, this capital N here, and it does need to be capital, stands for Newton. That is the official SI unit, the international standard, or Standard International. And people who've taken French in here probably have a better accent on that one than I've got. So if I wanted to indicate that the SI unit of force, put it in brackets like that and write a little SI right there. This is a symbol, just again, just shorthand notation, because physicists and mathematicians don't feel like writing words. Is equal to, yeah. This is saying that the international standard of force, unit of force, is equal to Newton. This is just shorthand notation for that.
What's a Newton?
What's a Newton? It's just a unit.
Oh,
So if somebody asked me what my weight is, I could say it's about 220 pounds, or I could say it is a little over 1,000 newtons. Somewhere around 1,000 newtons.
okay.
It's just a different unit.
It sounds like my kids is gonna be so tired of me.
But I think I'm just part of that.
I said, it sounds like my kids is gonna be tired of me.
Oh.
That's what I'm gonna be talking about at home.
They're gonna rejoice because we're talking about physics at home. You might have noticed, and it's in one of the videos, my hearing is not great, and the masks really do not help. So if I need to speak louder or you don't understand me, that's fine. I will ask you to repeat some things. And let me apologize now. I have had my hearing checked many times, and it's not enough for a hearing aid. Some of it is just age, but I do have tinnitus, which just adds to the joy. Just speak as clearly as you can if a cloth is over your mouth. Speak with confidence, even if you don't feel it. Okay, so we have this shorthand notation. Oh, back over here. All right, so 3 newtons I hat. Well, we're going to keep the same convention here.
We got
There we go. As a team, we've got it. If I ask you for a force, then I need the direction. There's another shortcut we can take. It's not as, it's a shortcut we can take only if it's a one-dimensional problem. As long as everything is along a line, I could just say to the right is positive, or to the left is positive, whatever your mood is. And so this one would just be force is equal to 3 newtons, and this is force equal to negative 3 newtons. But this only works as long as we're dealing with a one-dimensional problem. And we'll deal with quite a few one-dimensional problems, but the I hat, and then we'll add some other hats in a moment, works no matter how many dimensions you do. All right, questions here, because I'm about to complicate it. More than notation, a conceptual bit.
Are we always supposed to have that line over the I?
If we're talking about a force, then yes, you need a line over it. Oh, so actually, before we do this one, let's talk about what happens if you don't have it. This represents just the magnitude. If I don't have the vector symbol over it, we're talking about we're ignoring direction. So so here, force is equal to 4 newtons. No directions involved because I'm not talking about the vector. This is what is known as, I'm asking for the magnitude of the force. So this would be magnitude of the force. Or amount of force, or size of force, whatever makes sense. Of course, there's a notation we also do. That also says the same thing.
Okay.
All right, it might seem overwhelming right now. You'll get used to the notation after a while. It's day 1. It'd be cool if everybody understood it all perfectly right now, but that would make you the first class ever to do that.